Good day everyone. In this video, we'll be discussing on how elevators, escalators, and conveyors work, each components together with their types and functions. First, let's talk about elevators. An elevator is a platform that could either be open or closed and is used for lifting or lowering both people and goods to upper and lower floors. Most modern elevators are propelled by electric motors with the aid of a counterweight through a system of cables and sheaves, or pulleys. Elevator is also called as a lift. It is a car that moves in a vertical shaft to carry passengers or loads between levels of multi-story buildings. The most common configuration of elevators is to have two panels that meet in the middle and slide open laterally. Some elevators can also be traveling horizontally in addition to the usual vertical motion. So there are standard elevator layouts. First is the arrangement A. It is where the car has a side opening door and the counterweight is located at the back wall. While the arrangement B is where the car with a central opening door and the counterweight is located at the back wall. Arrangement C is a car with side opening door and the counterweight is located at one side. While the arrangement D is a car with central opening door and the counterweight is located at one side. So next is the components that make up an elevator. Here are the components of an elevator: elevator car and shaft, the sheave and motor, control unit, counterweight, machine drive, counterweight guide rail fixing bracket, car guide rail, counterweight frame, counterweight buffer, overspeed governor, control cabinet, apron, landing doors, tension pulley, and car bugger. We'll be discussing first the elevator car and shaft. Elevator car is the vehicle that travels between the different elevator stops carrying passengers and goods. Lifts in buildings are normally totally enclosed by a shaft that will rise vertically through the building and often terminate above roof level. The construction of elevator designed it to be encased within the elevator shaft and to be used to transport people and various objects to different levels in a building. So elevators come in a few different sizes, all of which have been designed with at least one door and work off of a motor or hydraulic system that pulls them up and lets them back down again. It is usually a heavy steel frame surrounding a cage of metal and wood panels. And next is the shaft and motor. Elevators that are raised and lowered by steel ropes that are connected to a counterweight and to the elevator car are motorized ones. The counter is to stimulate the weight for the elevator car at 40% of its capacity. This is to help in reducing any strain on the motor as well. The sheave is what the pulley is called. It has grooves in it and lets the roof be lifted, raised, and lowered. The sheave is connected to an electric motor. When the motor turns one way, the sheave raises the elevator. When the motor turns the other way, the sheave lowers the elevator. And it is the motor that keeps the sheave moving in the correct direction, taking people where they need to go. Next is the control unit. The control unit or motor and the sheave are all housed in the control room, which is generally in a location at the top of the elevator shaft. This is where the signals of each floor's controls go, and then they are translated through the system to tell the motor whether to move up or down. Once the elevator has reached its destination, there is a signal sent to the control room for it to either stop and let passengers board or exit it. There has been software installed in a computer that monitors the travel patterns, along with specific instructions that have been programmed into the control unit with the resting locations and signal priorities. Next is the counterweight. A counterweight is used for reducing stress on the motor because it is constantly being strained from the continuous lifting and lowering of the elevator. The motor works with the counterweight repelling the elevator in the upwards direction and then in the downwards direction. To keep the elevator and the counterweight from swaying, guide rails were also designed into the construction, making it a smooth ride in both directions. And the guide rails, it is what allows for the safe and precise movement of the car and counterweight. This rail offers a path for the elevator to ascend and descend. The component which comes into contact with the guide rail and the car is called the guide shoe. Elevator guide rails are components of elevator systems that define the path along which the elevators ride. An elevator should not be expected to operate regularly and safely on guide rails that do not possess the minimum quality standards and that are not installed properly. So next, types of elevator. First, the traction elevator. This type of elevator operates via a pulley system using steel ropes or belts and a counterweight to move the cabin up and down. There are two types of traction elevators: the gearless traction and geared traction. First, the gearless traction elevator. They don't have a gear for speed regulation. This explains why they can move as fast as 2,000 feet per minute and can also travel a maximum of 2,000 feet. They are the best option for skyscrapers. So gearless traction machines are low speed, high torque electric motors powered either by AC or DC. Next is the geared traction elevator. It is made up of a motor that has a gearbox attached to it. The main function of these gears is to power the wheel that moves the ropes. This type of elevator can travel up to 500 feet per minute. The maximum distance it can travel is 250 feet. Geared traction machines are driven by AC or DC electric motors. The next type of elevator is the hydraulic elevator. These are normally given support by a bottom-placed piston. The purpose is to push the elevator car up while an electric motor forces hydraulic fluid down the piston. When it is time for the elevator to come down, the valve releases the hydraulic fluid from the piston. The main reason hydraulic elevators are popular is because they are more affordable to set up and still have relatively lower maintenance costs when compared to other elevators. Hydraulic elevators utilize more energy because they use an electric motor that works against gravity. You should regularly check the hydraulic fluids because a small leak could easily lead to a catastrophic event or become an environmental hazard. And hydraulic elevators are classified into three: the rope, conventional, and hole-less hydraulic elevator. First would be the roped hydraulic elevator. This type applies the use of both ropes and a piston to enhance the motion of the elevator car. The maximum distance it can travel is about 60 feet. So, roped hydraulic elevators use both above-ground cylinders and a rope system, allowing the elevator to travel further than the piston has to move. Next would be the conventional hydraulic elevator. It is designed with an elevator pit. It comes with a sheave that extends beneath the floor of the pit, which accepts the retracting piston as the elevator descends. As the elevator begins to drop, the pit supports a retracting piston. So they use an underground hydraulic cylinder that are quite common for low-level buildings with 2 to 5 floors and have a speed of up to 1 meter per second. Next is the hole-less the hydraulic elevator. It is similar to the conventional one, but it doesn't require a hole or sheave fixed below the pit. It has telescoping pistons at the base of the pit. These pistons allow the elevator car to travel up to 50 feet. There is also a design that has non-telescoping pistons, which can only allow up to 20 feet of travel. Holeless hydraulic elevators were developed in the 1970s and use a pair of above-ground cylinders, which makes it practical for environmentally or cost-sensitive buildings. The next type of elevator is the machine roomless or MRL elevator. This type of elevator has a machine fitted in the override space, and it can only be accessed through the top of the elevator car whenever maintenance is required. This type of elevator can only travel a distance of 250 feet with a speed of up to 500 feet per minute. So most elevators are designed with a machine room located above the elevator shaft. MR elevators are traction elevators that do not have a dedicated machine room above its elevator shaft. So they are gaining popularity with mid-rise buildings because they conserve energy and require less room during construction. And the last type of elevator is the vacuum or air-driven home elevator. These air-driven elevators operate based on the natural laws of physics. It was introduced to the elevator community in 2005. Vacuum elevators do not use any cables or pulley system to operate. It was constructed with polycarbonate and aluminum materials. This lift system is basically a tube in a sealed vacuum. Because this type of elevator is available in three models, ranging from a single passenger to a three-passenger wheelchair accessible model. They are mostly used in residential applications. And vacuum home elevator is also known as pneumatic elevator. It uses vacuum technology to power the platform between floors. Turbines at the top of the elevator shaft suck air out of the tube, which pulls the cab upward. When the cab reaches the desired level, the brakes secure it at the proper height.
So the next topic is all about escalator. An escalator is a moving staircase which carries people between floors of a building or structure. It consists of a motor-driven chain of individually linked steps on a track which cycle on a pair of tracks which keep them horizontal. Escalators are often used around the world in places where lifts would be impractical or they can be used in conjunction with them. Principal areas of usage include department stores, shopping malls, airports, transit systems like railway or railroad stations, convention centers, hotels, arenas, stadiums, and public buildings. Escalators have the capacity to move large numbers of people. They can be placed in the same physical space as a staircase. They have no waiting interval except during very heavy traffic. They can be used to guide people toward main exits or special exhibits. They may be weatherproof for outdoor use. A non-functional escalator can function as a normal staircase, whereas many other methods of transport become useless when they break down or lose power. So these are the components that make up an escalator. First is the landing platforms. Landing platforms are the two platforms that house the curved sections of the tracks, as well as the gears and motors that drive the steps. The top platform usually contains the motor assembly and the main drive gear, while the bottom holds the return gear. These sections also anchor the ends of the escalator truss. Each platform also has a floor and a cam plate. The floor plate provides a place for the passenger to stand before they step onto the moving stairs, flush with the rest of the floor and usually hinged to allow easy maintenance access, while the cam plate lies between the stationary floor plate and the moving step. So name for the cleats on its edge which mesh with the matching cleats on each step. The interlocking cleats help to minimize the gap between the stairs and landing, preventing objects or persons from becoming caught in it. Second is truss. The truss is the hollow metal structure that bridges the lower and upper landings, composed of two side sections joined together with cross braces across the bottom and just below the top. The ends of the truss are attached to the top and bottom landing platforms via steel or concrete supports. It carries all the straight track sections connecting the upper and lower sections. Third is the balustrade. Balustrade is composed of handrails, balustrade panels, and skirt panels. The handrail provides a handhold for passengers while they are riding the escalator. The handrail is pulled along its own track by a chain that is connected to the main drive gear by a series of pullleys, keeping it at the same speed as the steps. On the other hand, balustrade panel being made of either metal, sandwich panel, or glass. The balustrade panel supports the handrails of the escalator. It also provides additional protection for the handrail and passengers. Some escalators have direction arrows on the ends of the balustrade, while skirt panel is the bottom of the balustrade. It is notorious in this art for being a frequent site of injuries and failures, due to the possible entrapment of materials in the machinery. The fourth one is the trucks. The truck system is built into the truss to guide the step chain, which continuously pulls the steps from the bottom platform and back to the top in an endless loop. One truck guides the front wheels of the steps and another guides the back wheels of the steps. The fifth one is steps. The steps themselves are solid, one-piece, die-cast aluminum or steel. Yellow demarcation lines are sometimes added to indicate their edges. The steps are linked by a continuous metal chain that forms a closed loop. The sixth and last component is motor. Escalators are driven by a motor and chain system inside the truss. At its core are a pair of chain loop around the pairs of gears. The gears at the top of the escalators are turned by an electric motor, which in turn rotates the chain loops. Safety is a major concern in escalator design, as escalators are powerful machines that can become entangled with clothing and other items. Such entanglements can injure or kill riders. So, remember to take extra precautions while stepping on and off the escalators.
What is a conveyor system? A conveyor system is a fast and efficient mechanical handling apparatus for automatically transporting loads and materials within an area. This system minimizes human error, lowers workplace risk, and reduces labor costs, among other benefits. They are useful in helping to move bulky or heavy items from one point to another. A conveyor system may use a belt, wheels, rollers, or a chain to transport objects. What are the benefits of a conveyor system? Conveyor systems save time when transporting items from one location to another, as they can be inclined to span multiple levels. They can make it simpler to move items up and down floors, a task that, when performed manually by humans, it causes physical strain. Inclined belts can automatically unload materials, eliminating the need for someone to be on the opposite end to receive pieces. There are three main parts of the conveyor system: the belt support, the pulley, and the drive unit. Each component plays an essential role in the conveyor unit's operation. While all conveyor system contains these parts, designs vary in the construction materials and where each component is located. Belt support is a component that ensures the belt moves smoothly. If the support unit is not firm, the belt sags when worker place a heavy object on top, and the sagging causes the belt not to move smoothly as it should. The use of a firm support unit keeps the belt taut and running efficiently. The pulley system is an external component used to control the belt movement. Each unit has at least two pulleys, one that operates under power and an idle one. More complex conveyor systems may have additional rotors throughout the frame. The drive unit allows the system to move. The unit contains a counter bearing that keeps the parts moving efficiently. This unit also allows for the belt to move in reverse and manage the repeated adjustments in direction for some systems. Some conveyor systems are manually operated. These systems still use a drive unit, however, it is not motorized. How do conveyor system works? Conveyor systems consist of a belt that is stretched across two or more pulleys. The belt forms a closed loop around the pulleys so it can continually rotate. One pulley, known as a drive pulley, drives or tows the belt, moving items from one location to another. The most common conveyor system designs use a rotor to power the drive pulley and belt. The belt remains attached to the rotor through the friction between the two surfaces. For the belt to move efficiently, both the drive pulley and idler must run in the same direction, either clockwise or counterclockwise. While conventional conveyor systems, such as moving walkways and grocery store conveyors, are straight, sometimes the unit needs to turn to deliver the items to the proper location. For the turns, there are unique cone-shaped wheels or rotor which allow the belt to follow a bend or twist without getting tangled. There are many types of conveyor systems. Each type of conveyor serves a specific purpose. Some of these are belt conveyors. It is also known as conveyor belts. It is actually the belting material. A belt system is one of the simplest conveyor types. It moves parts from one end to the other. Belt conveyors are the most common and simplest form of conveyor and can have variable speeds. They have a moving belt that rests on a steel frame that supports the belt and the material being moved. Ones that have a supporting frame underneath are referred to as sliding style. When the belt is supported by closely placed rollers, it is called a roller belt style. There are many types of belt conveyors. Examples of these are roller bed conveyor, flat bed conveyors, and modular belt conveyors. Chain conveyors. Chain conveyors can have two or several sets of chains that make contact with the bottom of items to be moved. The material rests on the chains as they are moved. Chain-driven conveyors are ideal for items with uneven bottom surfaces or ones that are very heavy. Ones that have a heavy frame can have pallets placed directly on them. Due to the types of items chain conveyors move, they operate very slowly. Live roller conveyor or chain-driven live roller. If we combine the rollers from a gravity conveyor with the chains of a chain-driven system, we can link the rollers. Add a motor and gearbox, and now we have a live roller conveyor or chain-driven live roller system. It is used to transport pallets, seats, tires, and containers if fitted with loose plastic sleeves over the rollers. An escalator is an example of a chain-driven conveyor system. Instead of having a pulley system that pulls items along, the chain conveyor uses a towing system that pulls the steps in an upward or downward motion. Motorized roller conveyors. These modern motors are at the heart of today's sophisticated distribution centers. They use one or more motor-driven roller per zone to create a series of zones along the conveyor. Motorized roller conveyors use motors placed along the conveyor frame to power evenly spaced rollers. The design is similar to a gravity conveyor with the addition of motors. The number of motors is dependent on the load to be moved and the overall design of the system. The connection between the rollers can be a chain or a belt. In some systems, there is a sensor that starts and stops the motor to avoid pieces getting packed together. Gravity roller conveyors. It has a set of equally spaced rollers connected to a side frame. The position of the rollers provides a surface to place materials for movement. If a gravity roller conveyor is tilted or mounted on an angle, materials move by gravity. Though pieces of varying size can be loaded on a gravity roller conveyor, workers need to be cautious of larger materials running into smaller ones. Gravity roller conveyors are used by shipping companies to load and unload trucks. Slat conveyor. Slat conveyor is simply a two-strand chain system with slats connected to the chain and a guiding system for the slats. This creates a smooth surface to which tooling details or fixtures are mounted that is used to hold parts in the desired position. Overhead hand push beam systems. Moving on to the overhead family of conveyor types, the simplest systems are hand-pushed beam trolley systems. We use enclosed track or I-beam section as a track. These types are extremely versatile, easy to set up, and affordable. They are mounted above the workplace with roof-supported or floor-supported steel structures. Motorized overhead conveyor or monorails. One of the most common types is an overhead conveyor with a trolley connected together with a chain. The chain can either be enclosed or open below an I-beam. These style of material handling systems are installed in nearly very high-volume production facilities. Power and free conveyors. Power and free conveying systems are designed to move parts through the production and assembly process. Items being assembled move from workstation to workstation. They stop at each station to be worked on and they moved on. Power and free systems are a special form of overhead conveying system. Over-under conveyors. As the name implies, they go over and they go under. It is available in hand-push, motorized, and power and free versions. Inverted monorails and inverted power and free. It is just like their overhead configurations, except the truck that is on the ground and the load is above the truck. It is useful in paint finishing applications to avoid dust or oil dripping onto the parts. It is widely used in automotive final assembly operations.